Hello, let us see how to solve this problem. So basically what is given is there is a RAM, okay, and then this RAM is a 4K RAM, okay. So now this RAM, the memory range of this RAM need to be calculated. Like for example, it starts from 00 whatever x 000 based on the bit size, and then it goes till FFF or whatever. So example, so now this memory range is not known. Only thing that is known is there is a chip select for this, and this chip select is derived from the address bits. That means A15 bar into A14 into A13, and as this is a 4K RAM, basically definitely there will be some address bits to select this 4K. At least minimum address bits are required, right? So 4K is like 2 power 2 into K is nothing but 2 power 10, right? That means this is 2 power 10 plus 2, which is 2 power 12. So that there are 12 bits in the address bus. So if you see the address bus, it is 12 bit. That means it starts from A0 so on up to A11. Okay. So one might get a doubt in this question, because it's given as 4K RAM directly, and we know that these are the addresses. Then directly it should be 11 bit, right? But the question here is it depends on whether it is 11 bit or whatever, based on the internal memory organization. So we are not sure for each location how much data it is stored. It is just saying a 4K RAM, the capacity, and then we have to find out the memory range. So because the total memory data bits are not known, we have to take a different approach to find the memory. So now here one can see from this that this 4K has 4K RAM has the address bits 0 to 15 actually, because 11 is as per the 4K that is mentioned, and then there are additional address bits that are going to select the chip select. So now if you start arranging this in a form of a truth table, A15 bar, and then this is A14, and then A13. So these are the 3 bits. So for this address to be selected, you need A15 to be 0 always, and then A14 to be 1, and A13 to be 1. So that means we know these 3 bits. Now coming to A0 to A11, okay, let us start from the MSB bit A11, A10, right, so on up to A0. Okay, if we divide them into A1, A2, A3, 4, 5, 6, 7, 8, 9, 10, 11, because each hexadecimal number is represented by 4 maximum of 4 binary numbers. A0 to A3 is one set, and then A4 to A7 is one set, A8 to A11 is one set. So if you see this, if you see the maximum value of this minimum value, it could be 0, 0, 0. The maximum value, so 0 is nothing but 4 zeros here, 4 bits, right? That is the memory maximum location. And then the minimum location, sorry, the maximum location is 1111, because it can range up to 1111. That is what this 4K meant here. So that means we know this A0 to A11 bits, this is the range, and A13 to A15, this is the range. Now in between these 11 and there is no 12 here. So if you take 12 as a don't care bit and you try to give it either 0 or 1, so you can you place it as x. So that means this is f maximum is f f f, right? Three f's because 3 ones are there, and if you treat this as 1, this comes as 0 triple 1. 0 triple 1 is nothing but 7f, right? If you treat this as 0, it comes as 6 triple f, okay, right? Because if you take this as 0, 0 1 1 0 is nothing but 6. So the maximum address here could either be 6 triple f or 7 triple f based on the A12, because A12 we are not clear what is the condition, it is not given, so we are assuming that it could be either 0 or 1. Now considering the minimum memory location, similarly if you put 0 here, so it will be 6 triple 0, right? And if you put 1 here, it is 7 triple 0. So these are the two memory address ranges where this 4K RAM could be. So this is one of the typical problem where the direct addressing is not mentioned. The addressing should be understood based on the chip condition, chip select condition. So the main point the student who is solving this should understand is that to enable this RAM, this chip select should be high. So for this should be high, this is the condition. So we have to put this condition as always 001, such that you can always access the memory. So based on this bits, and also a student has to guess that there is a 12th bit that is missing, which can be considered either way. So if your answer has 6000 to 6FFF and 730 to 7FFF, either of them could be the answer. If both of them are present, then that is the correct memory location. Thanks for watching.